Hello everyone, we're continuing the topic of MOSFETs and we're going to look at MOSFET transfer function today. The goal is to find out how Vout changes if you change the value of input signal or Vi from 0 volts to VDD. So I'm looking to draw a graph that relates Vout to Vi. And the circuit equations that I'm going to use for this circuit configuration are VGS equals to Vi. This is gate to source voltage from gate terminal to the source terminal. And I know the characteristic equation for the MOSFET, an equation that relates ID to VGS and VDS. And this is my drain to source voltage, that is the output voltage as well, and the drain to source KVL that tells me how Vout is defined. Vout or VDS is equal to VDD minus ID times RD. So let's start with different values for VGS from 0 to VDD and see how the value of output voltage or VDS changes. This is the same as Vout and this is the same as Vi. So for small values of Vi or VGS, when the value of Vi is less than threshold voltage, I'm in this region, and in this region Vi is less than threshold voltage. From there, ID drain current is equal to 0, and from the KVL for drain to source, I know that VDD is equal to RD times RD plus VDS. So because ID is 0, VDS or my output voltage is equal to VDD. So in this region, when you get to the value of VGS being greater than threshold voltage, VGS is increased beyond threshold voltage. So there is a channel formed underneath the gate, and ID is small at this moment because you have this channel induced underneath the gate, but VGS, the value of gate to source voltage is still small, and as a result ID is small. So if ID is small, again by looking at the drain to source KVL, I have VDS being a value close to VDD because this is small. VDS is close to VDD. VDS is a large number greater than overdrive voltage. This transistor operates in saturation region. So V overdrive is defined as VGS minus V threshold, which is a small number here because VGS is close to threshold voltage. Now I keep increasing the value of VGS, and I'm getting close to the point to the left of point B. At this point, ID is large because VGS is increased compared to point A. ID is large. From there, VDD equals to RD times ID plus VDS. If this ID is a large number, RD times RD is also large, and VDS is going to be a small number and smaller than VDD. At some point, when you get to point B, the value of VDS is going to be equal to V overdrive voltage, which is this point. VDS at point B equals to overdrive voltage, which is VGS minus V threshold. Beyond this point, if you increase VGS, the transistor is going to be operated in the triad mode. So this is called the edge of saturation. For VGS values less than this point B, the transistor is going to operate in the saturation region, providing that it is greater than threshold voltage. For VGS values greater than this value, the transistor is going to operate in the triad mode. And that's the transfer function for MOSFET in the given circuit.